Welcome back to our Scala to Spark class, and we will look at chapter 26 of our Sparks, the definitive guide. We will look at classification tasks. This is one of the three major categories in machine learning of tasks, of type of tasks we do. So this type of task is when we are predicting something discrete, basically some sort of class or type or category, red or blue, yes or no, white or black, true or false. Give a mortgage or don't give a mortgage, give credit or not give a credit. That's binary classification. Of course, you can also provide multiple labels as well as a classification task. So the main thing is you are giving discrete values, so concrete and discrete. So let's take a look. Right. So let's take a look how it works. Right. So I will start. I have uploaded also some files, resource to Git, to our course repository. So if you see resource, there will be binary classification and multi-class classification. It should be updated in Git. In fact, I will do it right now. Right, so those are also here. Those are temp, those we don't, but these we do. And added data-5, added resource files for classification. Right. Okay. And we'll see how it goes. So yeah, so it's a task of predicting a label, and so of course we'll need some, by definition we need some labels, of course, right? So let's start a new file, new Scala class object day 35 classification, and extends app, and we will be doing so print line chapter 35, wait, not 35, 26, classification. Okay, so some help here, right? And I will give everything here, right? So the only thing is that's not available here. Is that this multi-label prediction. So let's go through all of this information here, right? So we have, again, there are plenty of use cases, right, like I mentioned. So the types, right, binary is the simplest one, right? We have yes or no, only two labels, right? For example, fraud analytics, right? Whether it's, or spam, for example, right? Is it spam or not, right? Or also, then of course, there's multi-class when you have multiple labels, rainy, sunny, cloudy weather, for example, right? So again, but it's always finite, finite class, so only limited number of classes. You don't have a, unlimited number of classes. So the last one is multi-label, when you could possibly have multiple answers, like maybe a book is about science fiction, maybe a book is about romance, right? So it's possible, right? So it could be multiple labels, right? So so for example, also tagging images, right? What kind of people, what kind of objects appear in an image? That's a multi-label classification task, right? So Spark as default, this is again a couple of years ago, has binary multi-class classification built in. There's no support for multi-label natively. Of course, you could add from some other library, of course, right? So that's another possibility, right? So of course, the whole idea is this: get the data in the right format, right? Maybe change some hyperparameters for specific algorithm, right? And then, of course, apply this to the training set, and of course, then you validate against the test set, right? And of course, also Spark, of course, tries to build these models for a larger scale. Not every cool algorithm works with a large amount of data, basically. So that's the thing, right? So you can see here, for example, logistic regression actually works from one feature, of course, right, to 10 million features. Well, this is in 3,000 features, right? Training examples, no limit. So of course, output classes, again, you could have up to, well, still pretty large amount. So for example, you have 1,000 features, right? And you have possibly labels, 100 labels. That's 1,000 times 100. That's 100,000, output possibilities, and that's allowed basically, right? So again, no limit basically, right? So again, of course, if you have a billion rows, right, of data, of course this will take a while, right? So okay, but let's start about this. Let's start with loading some data, right? So let's see if this works. So, and we'll check what we have here. Let's see. Of course, you need to get Spark, right? Well, Spark is get Spark. My Sparky. And we will go here. Right, binary input. Right, of course, it's a data frame, right? Of course, it's also not here, but it's in source resources binary classification. And if you check it out, it's a older style. It's a multiple zipped multiple part Parquet file. So it will be interesting to see if this is recognized by newer version of Spark. That's a good question now. Source resources, and let's see if we have anything to check, right? Bay input and show false, right? Let's take a look. Let's see. Now we'll run it. And hopefully, so we are casting or label the answers, right, as double, right? It actually was probably numeric, but it was not probably double originally, right? Because of course, remember, Parquet is actually a format which remembers data types. So we will see if this works. Okay, again, the zip, there is some optimization of library which doesn't work, but okay, so label, yes, looks good, right? So we have 1, 2, 3 features, right? It's a vector, right? Vectorized, so ready to go. You don't have to do anything, right? Don't have to do any preparation or previous chapters, of course. In real life, you had 3 columns, you have to put them in a vector, of course, right? So, and we have 2 answers, yes or no, basically, right? Pretty simple, right? And it looks like we only have, what's hilarious is I think we only have 5 rows, right? I believe so, right? Let's take a look, bay print line, I think bay input. I'm kind of curious what's going on here. Right, bay input, describe, right, and show, right? Kind of curious, right? All right, so this is describe, it gives you a data frame, yeah, okay, so we'll check. So, okay, but, so that's our data, right? And, right, of course, we won't have time to talk about exactly how the algorithm works, but for example, logistic regression, it's closely related to our next theme, which is going to be regular regression. But of course, there's a major difference is not only is that logistic regression actually gives you a specific, well, it gives you probabilities of belonging to a specific class, right? You can check, if you check some answers around, you see the difference, like we'll be doing linear regression, right? On logistic regression, you actually have a sort of a distribution of these probabilities, right? So, so that's, again, the main thing is the answer is not continuous, right? In logistic regression. So, we'll use also, hopefully we'll get to decision trees, right? So I'll add some, so here are some hyperparameters, right? Also, there's also something called training parameters. Basically, how long do you want to go before you want to train, right? So, on prediction parameters as well, right? So, so we are going to use, again, it's always a good idea to start with the default, because of course the designers of this library, they already thought about some sane default values, right? And only then, when you may have some extra needs, maybe you will want to proceed, right? So, right. So again, so simple example. I'll just give you an example here, right? Right. Yeah, so here, right, so this, oh, sorry, like this. Okay, and we are going to basically just import the library, fit, right? Of course, we can explain the parameters, right? On this is that help here basically, and we can do the fit, and then our model is the working model basically, right? We can make predictions, right? So I'm still kind of curious about how big this data input set is, right? Because we are fitting, we need of course this, right? Yeah, okay, let's run it, right? So this is going to be a working model, right? Okay, right. So everything worked. It showed all the different, explains all the different parameters basically what you can for this algorithm which you can use. So yeah, so there's only 5 items, right? It's kind of hilariously small. So if you think about it, this our data set, right? It's zipped in 7 or 9 files, but it has only 5 rows, right? So pretty silly data basically, right? Pretty silly data set, but you know, small 5 vectors of size 3 basically, very tiny, right? But we can make predictions, right, already, right? And we can also what we can do is, of course, it's not going to be very useful at the moment, right? Because it's such tiny, way too little, right? But so we can get the coefficients, right? We can get the intercept basically, right? And we can also make predictions basically as well, right? Right. So let's think about that actually, right? You can get the right. So you can see. Okay. Well, let's check this, right? So let's check this, right? You can get some about some algorithms. You can get some information how the model works, and logistic regression is one of those where you do get some idea, right? Again, so let's take a look what we have, right? Okay, so it gives you, okay, so this gives you the intercept and of course the 3 coefficients for this, because you have 3 columns, right? So you have 3 features, right? So you have 3 coefficients, right? And of course the intercept, right? So again, maybe it's not how say, maybe not too useful, maybe not too obvious, right, what the values are, but basically you can see how the features, depending what features, how they affect the prediction basically. So again, so how do you use it? Basically you use LR model, right, and predict, right? Exactly. And of course you have to give it a features. So predict features vector, right, and you will get an answer basically, right? And of course I think you can also do give it a, well, let's say, okay, let's do this. Can I do this? Can I do basically advanced features vector, right? But can I do basically let's say B input select, of course, expression. Let's see. Advanced vector. And of course features, basically it wants this type of data basically, right? Right, so how would I get it out again? We would need to, right, we need this vector, we need again a vector assembler, I guess, right? That's what we would need. And right, so basically, right, that's probably what would we want to do, right? I wish there's maybe, I wonder if it takes regular array, right? That'd be nice, right? I don't know. I don't think it will work, right? It won't work with, this is not just regular, it won't work with this, right? Let's say, you know, 3, 5, and 7, right? This won't work, right? That's a vector of integer, right? But once, it's not a right integer. Oh, but let's see. Will it actually work? I don't know. It's a vector of double, but it's not that vector, unfortunately, right? This is our Scala vector, right? But it wants outcomes double, right? Yes, okay, right. Features, right? Vector, right. So this is Spark, right? I wonder, can we make it actually give some data, right? Of course, if we didn't have a data frame, right, it'd be kind of a, you know, out of a row. Can we do it by hand? Let's see, right? Once, right? Can we do it? Let's try it. My vector, right? Can we do this? I'm trying. See, vectors, right? And can we do this basically? Like, let's see. I don't know. No, I guess not. Right, because of course it's a no, it doesn't work like that. Factory methods. Can we do something? Create a vector. Right, it'd be nice to do it by hand, right? Of course, right? To make again. So, or maybe we could do a data frame, right? As vector, because we would like to do this here. Predict cast as vector. So let's do this again. Scala Spark cast sequence to Spark vector. Yeah. Right, we check this, right? Spark Apache. Right, how to do it by hand, right? So again, it's vector assembler. Is there we do vector slicer, perhaps? Again, do we really have to do this? That's assembler, basically, right? Of course, you're not really meant to do only a vectors, okay. Oh yeah, of course, right? We could do this. Okay, so vectors dense, right? Let's do this, right? Yeah, that should do it, right? So, and of course I import it from ML, right? And now I should be able to do it, right? Vector, right? And print. So this will give me a double, right? And this will give me an answer, right? You know, I have some, you know, whatever I have, right? Whatever I have, what kind of values I have, right? 3 features, right? So basically it should give me an answer, right? Yeah, 0 or 1. So this should provide me, will provide me an answer 0 or 1 in this case, right? And of course then you decide what 0 represents, you know, and what 1 represents, right? Of course, because those are numbers, right? Labels, but of course you have to know the actual, you know, what the human name for it is, right? Whether it's, you know, approve, is it spam or no spam, right? Or is it a, you know, fraud or not fraud, and so on and so on. Okay, but let's see this work. And yeah, of course, it provides this answer, right? So it says, okay, these numbers, these 3 features, well, my model says, okay, it's 1.0. Of course, again, you have to see it in action with, you know, much larger. Of course, you'd have to, this data set is really only, so our data set is really small here, right? In real life, it should be at least a few hundred, if not thousands of rows, right? Of rows, basically, of course. So, okay, but again, so you can, of course, here, right? You can provide set. You see here, right? LR, right? I think you can do it here, right? you can set fit. You can set. You see, you can set all kind of hyperparameters. Yeah, so you can do. You can use LR set. You know, on to set various hyperparameters. Right. So here, basically. Right, and you can do this example. You can see here. You say, okay, max iterations. Maybe, you know, for example, LR max iteration. Oh, sorry, not like that. Control Z, for example. Let's say 50. You know, then you can do, for example. Oh, sorry, not like that. Not like that. Oh, it's not a method. Ah, it's an int parameter. Right. Ah. It's not. It's a parameter actually. Do I have to set it like this? Interestingly enough, do I have to do it like really like this? That's interesting. Oh, set. Sorry, set. It's a set max. Sorry, yeah, set of course. Right, 50. Right. So this should be able to. We can chain it. Right. It comes out logistic regression. Right. Yes, the same type. Right. So we can keep chaining. Right. We can keep chaining. Right. Of course. Right. And we can keep since sets. Right. Typically. Right. Set, for example, you know, threshold, aggregation depth, fit intercept. We can do all kinds of these hyperparameters, you know, and of course, how can we set, of course, columns, output prediction columns, and all the other hyperparameters we can do here. And of course, you could also do set the values here also, right? Use set here, right? So you could do it immediately here, for example, right? Also, you know, you could do it set. You know, max iter here as well, you know, 150 for example, right? Right, you can do it here, right? This side you can adjust parameters later as well, right? So what else can we set here? I don't know. Like I said, I don't use logistic regression too much. So what else? Elastic, right? 0, 1. So we could say set elastic, maybe I don't know, 0.7. I don't know. Let's take a look, right? So, and so on, right? It has to be range. And you have to read, of course, this about. So these parameters, of course, will be different from each different model of you know, type of algorithm. So let's run it. Right, so it works still same way. Actually, I think you can see the weights change a little bit. So we change max iteration height, right? How many times so how many times the algorithm will run? You know, it keeps track, of course, right? So you know, it's basically on. What else? Right, so it worked. Right, so let's move on to. Let's see how much time we have. Yeah, we're doing good. Let's move on to the my favorite, which is decision trees, right? So, which is basically doing something which we played all as kids. We played around. Is that we can basically a friendly. One of the rare algorithms, right, in this whole field that you can actually understand as a human, basically, right? It's not a complete black box. You actually see how it chooses. For example, the example here is right. So if a feature is whether somebody likes ice cream, and so if you want to predict whether they will eat ice cream if you give them a present, you know, as ice cream, right? Whether they like ice cream, that would be a very probably useful feature, right? So right. So if decision trees basically use an if type of statements, they create a statement. It's like playing this game of 21 questions, right? When you say, is this black or white? Is it larger than 50? Are you older than 50? Or are you under 50? Are you over 25 or under 25, for example? Are you red or brown, right? Is your car red or brown? Are you married or not? And so on and so on. So these are yes, no type of questions, right? And it basically segments your answers in these different classes, right? So it's really nice, and it works also on multiple features, right? So very cool algorithm, right? So it can overfit extremely quickly, right? Because if you don't give it a very good, it will basically fit perfectly to the data you give it, basically, right? So let's take a look here. I wonder if we have any irises. I would love to see if I have any irises to give us a training set, actually, right? But we will see. So it has some cool. So maybe I'll show you what decision tree looks like. Decision tree, right? All right. Classifier, right? It's something like this, right? In Wikipedia, it can give you a pretty nice answer, basically, right? You've seen something like this, basically, right? Yes, no, right, right. Decision tree for a pretty morbid topic of survival of passengers on Titanic, right? So your algorithm will build something like this, basically, right? Can predict, basically, depending on age. So features are gender, age, right, and some other, what kind of siblings you have, basically, right? Unfortunately, those who had many siblings, they were much more likely to perish, basically, right? So I think here it was not really. Yeah, so most I think survived, right? And so those who had lots of siblings, they pretty much all died, unfortunately, right? So and the young ones, I think also more young ones, unfortunately, also died again. So right, so so that's again, the advantage of this type of algorithm is it gives you, well, basically, so you can print out the answers, basically, right? It goes through, right, and gives you the answers, basically. So what else? So where are we? Decision trees, right. So prediction parameter only thresholds, right? But so the whole input, right, will be basically like this, right? So we create a new parameter. I mean new algorithm, right? Basically here, Control Z, sorry, here, right? Then import it, right? We could set some we can set, of course, set maximum depth, set maximum depth, for example, right? You know, maybe let's say 4, right? You do not want the algorithm the tree to grow too large, right? That is ask too many questions, right? Right. So of course this is just an example. Of course this is not required, right? That's just a. It might be even already maximum depth already might be default, or even be 5. Yeah, actually it is actually 5. Actually in default is in fact 5, right? So no need for above method, above setter, right? So again, but otherwise, that's the beauty of this whole field, is basically you choose different algorithm, right? But it works, otherwise works very similar, right? You just say, okay, fit, right? Of course you can print explain parameters, but basically, and you have the answer, right? Fit, and basically a model. Of course, then you can make a prediction. Again, you can make a prediction, right? And I'll make a prediction on this my vector, right? On here, right? DT model, right? Will work same way. So decision tree predictor will work just like the linear regular. The logistic regression model. Okay. We can, of course, each questions will be same answer one. That's a good question. Let's see. For this kind of silly example, maybe we will want to do work with some flowers. Maybe. Let's see if I have my flower set. I will check if we can do this. You see? But prediction is different. This gave you answer 1, this gave you answer 0. Questions, what else could we do? Right, so again, 2 different answers. Of course, these are kind of silly. We would like to probably get some nice data set from irises. We'll talk about some flowers. Let's see, we have so much time. Yeah, we have some time. And we will read some flower data sets.